Today we're going to be doing an investigation into weight and mass. Just a reminder that mass, this kilogram mass, that's the amount of matter that it contains. Weight is a force, and it's the size of that force that we're going to be investigating that pulls it down to the ground. Now, usually when it comes to weighing an object or finding the weight of an object, we would use a Newton meter. So the Newton meter here, if I put my mass onto the Newton meter, I can then just read off the scale, and that will tell me the size of the force that the Earth is exerting on the mass, pulling it down with, and we call that the weight, measured in newtons. So here's the setup that I would like to use. I've got a spring attached to a clamp, attached to the retort stand, and I've also got a meter ruler, and I need to make sure that the zero on the meter ruler is level with the bottom of the spring. Now what I intend to do in the experiment is to take my mass hanger with my masses, and I'm going to place them one by one onto the spring and measure the extension in the spring each time. But before I was to do this, it's really important for any investigation you do to risk assess it, to look for any potential hazards. Now here I've got a metal spring that I'm going to stretch, and if I stretch that, then it could well snap and ping off, and a sharp piece of metal might go into my eye, which is why in this risk assessment I've decided to wear my safety goggles. So for the first measurement, I'm going to take 100 grams, which is equivalent to 0.1 kilograms. I'm going to place on my 0.1 kilograms, and I'm going to read, keeping my eye level with the bottom of the spring, just to measure the extension. Now I can see the extension here is, make sure it's stationary, and I'm going to level off, and it's 38 millimeters. I'm now going to take another 0.1 kilograms and place that onto the mass hanger and gently let it extend. Measure the extension again, and this time I can see the extension from its original length has gone up to 81 millimeters. Now I would continue doing this experiment until I have placed all of my masses onto the spring, or the masses had actually landed onto the table. Now in most people's homes I wouldn't expect you to have a spring or any of this equipment, so we're going to do this experiment at home. I've had a look around my house to see what I could find to take the place of all this lab equipment. If you don't have a spring, which I wouldn't expect you to have, you might have an elastic band. An elastic band works just as well, gives you slightly different results because it stretches differently to the spring, but it will still work. You may not have one of those. You might not have one of these either. This is an old exercise band, it's a piece of elastic. If you're going to use one of these, then you're going to have to use quite a weak one. Don't use a strong elastic band there. If you don't have one of those, this is called a pop sock, or a pair of tights will work like that. But actually anything that you can find around the house which you can stretch and that will spring back into its original shape, so any elastic material that's stretchy will work for this experiment. Also, you're not going to have masses in your home like these. Each one of these, remember, is 0.1 kilograms. Other masses you can use, things that you might have in your home. I found in my cupboards I've got these just food tins. Each food tin, it doesn't really matter, but this was a 400 gram, this is a 425 gram. If you can use cans of the same mass, then that's going to be best. You don't have to use cans either. Another thing that I've got, a packet of jacket potatoes. Each one of these jacket potatoes is probably about the same as those. Now I know that every jacket potato or baked potato is not going to have the same mass, but they're roughly similar. Something else, could have some apples. They're probably not quite as heavy, not as much mass as the potatoes, but again they're going to work. I'm going to show you how. Obviously you're not going to connect them to a mass hanger. I'm going to show you how to connect those up later. Okay, for the first demonstration I'm going to use the elastic band, the rubber band, and I'm going to use potatoes for my masses. This is my mass hanger, and to make my mass hanger I'm just going to attach this, just going to tie it round the handle to the elastic band. I don't want to pull that too tight, I don't want to snap it. I'm going to take the other end and I'm going to place that just over a door handle there. Now, at home, This is my house, so I don't mind me doing a little bit of drawing on here. I'm using a pencil, I'm going to do it very lightly. If you're doing this at home, please make sure you ask the homeowner before you make any marks here. You can get away without making marks at all, it's just a bit trickier. I'm just going to make a mark there. This is where the mass hanger, the plastic bag, is actually connected to the rubber band. Now I'm going to take my first mass and just put it gently into my mass hanger. Now it's only a small potato, so it's just stretched in a little bit. So with one potato, I'm going to make a mark on there. 2 potatoes and another mark. Now I've already checked that I can rub these off without leaving any marks. You must double check there. Can't emphasise that enough. I'll keep adding my potatoes in until the bag either hits the floor or I think that the rubber band is going to stretch too much. Secondly, I'm going to do this one with my tins of food instead, if I didn't have potatoes. So this time, when I place this, doing exactly the same experiment. I'm just doing this quickly. Obviously, if I was doing it, I would be marking them off. What I notice now, they might come down, it might hit the floor if you've got a different elastic band to me. So I've got a suggestion. You might not be able to do this in your house, but instead of hanging it off a door handle, you might be able to find something higher to hang it off. So if you just follow me up then, and you can see up here I've got something else that I can hang it off instead. So doing it that way, that would work just as well. Cool. Now if you couldn't find an elastic band to do it with, other things I suggested, I've also found a hair bobble. Hair bobble, not quite as good as an elastic band, but still going to work. If you have to resort to the tights, just tying the tights on, it's quite an easy thing to do. Tying the tights or pop sock around the bag, and then on the other end making a loop and putting that loop around the door handle will work as well. The measurements that I'm going to take, remember this is the starting position here, so I'm going to put the nought on my ruler. It doesn't have to be a big ruler like this, any ruler could do. If you don't have a ruler, you could almost estimate centimetres, or you could do finger lengths between them, anything like that, as long as you can get some results. Remember, this is going to be your dependent variable, the thing that you're going to be measuring. So here I can see that from the starting point to the first mark, which was the first potato, I can see it's 22 millimetres. To the second mark, which is down here, you may not be able to see on the camera, it's actually at 70 millimetres, and I would keep working down, down, down until I got to the last potato. Here's the table that I'm going to produce. I've got my mass, which is going to be the independent variable, the thing that I've decided to change, and I've got my extension. This is the length increase that the elastic band or pair of tights, whatever, actually achieved. So just using my ruler to make a neat-ish table. And so the unit that I've used is potatoes. This might be cans, and the extension of the elastic band naught had to be naught. After with one potato it was 28 millimeters, and for 2 potatoes it was 70 millimeters, and so on and so on. So I'd complete this table with all of my results. It would be good to have at least 5 different readings for the mass. So here are my actual results, and then just down I've had a go at plotting a graph. Now the sort of graph I've used is called a scattergram, or it's going to be a line graph, and I've plotted all of mine in. So on my x-axis I've got the mass, which was potatoes, and on my y-axis, which is the dependent variable, I've put my extension in millimeters. I've put my plots in there. When doing the graph, I've made sure that the interval between each of the x and y values is going to be the same. They're going up in the same increments there. Now for my line of best fit, this looks like a curve to me, so I'm not going to use a ruler for this, and I'm just going to draw in my line of best fit. Depending on what you used, whether you used a rubber band or a spring or a sock or a hair bobble, the shape of that graph is going to be slightly different. So that's today's experiment. For your write-up, I'm expecting a diagram of the work that you've done, a table of results, a graph with a line of best fit, and then a conclusion. A conclusion is is what your graph shows you. What can you find out from doing this experiment? For extension work, I'd like you to write about what you found difficult in the experiment, and if you were to do it again, how you would do it differently. For your challenge work, you could write about how the results might be different if you were doing this in different places in the solar system. So have a think about if you were able to do this experiment on Jupiter or the Moon or the International Space Station, how your results might vary and why. Just to reiterate, before you actually start your experiment, please make sure you're doing it in a safe manner. All good scientists risk assess what they're going to do first of all. If there's anything here that you don't feel safe or confident doing, don't attempt it. It's always best to have an adult around when you're doing it, and please do not make any marks on doors, furniture that cannot be removed. Remember, you can do this just without making a mark. You could just put a ruler there instead. Anyway, it's time to get on and get your work done now, and I'll see you next lesson. Make that nice and tight. Stop.